In this exercise, we'll use all of the knowledge that we built so far to develop this top plate of the cup coaster. If we look into the coaster, the base feature that we will do is to extrude the hexagon, so the polygon with a 6. Just to dimension that hexagon to have a length 80. In the mid of it to have then one of those circular cuts. Then we will array the circular cuts for the 6 times. And likewise, we can actually have both the circular cut and one of the holes made earlier. So if we array 2 of them together, it will also create this whole array. And we will only need a one more array, one more hole in the center. That will complete our coaster. And the coaster is in the millimeters. And let's say that we will cut it out of the acrylic, so I will use plastics acrylic as a material, and I will put that it is a 5/16 of inches. And I will have their mixed units, so I will put 5 divided by 16 IN. It will automatically convert it to a millimeters. Okay, so let's start the part. I will choose millimeters, MMGS, and I'm going to choose material to be plastic. Under plastics, and I will find the acrylic, and apply. I'm going to start placing a sketch on the front plane, and my first item will be a hexagon, so I will click on a polygon with a 6 and vertically aligned. And to be sure that it is vertically aligned, I will click on a vertex and click on an origin, and I will specify that these two are vertical. And the size of the side will be 80 millimeters. And that fully defines this base. Look back, so here is it. Now what we will do, we are going to extrude both this one for a 5 divided by 16 IN. And that's 7.9375 millimeters. Click OK. Why I use 5/16? Because I have an acrylic material of that thickness, so we can actually fabricate this part. And we can see it on the screen the same as it will be fabricated. Now what I can do, I can place the central hole, which is a 10 millimeter hole. And then I can, oh actually no, this is a 5 diameter, this is the 15, and I can place one of the side hole. As you can see in this particular case, we can assume that the hole is like at this distance from center. So how we are going to do this? We'll place the hole wizard. I will choose n-symmetric. I'm going with the 5/5 and position. Actually, it is a 5/10. So choose the 10. Position 1 will be anchored. Another one will be vertical, and I'm going to. However, I will do this in a separate hole wizard, and I will show you why. So the one hole wizard will just have my central hole. Second hole wizard will have that vertical hole. Press escape. I will click on a point and click on the origin point, make those two to be vertical, and then click on this vertex in a corner and click on a point and make those two to be horizontal, and that has constrained my hole. And I'm going to make a one of the hole here at the midpoint of the diameter 15, and that hole I'm going actually to sketch as a circle, which is coincidental with the midpoint and with the diameter Is it diameter or radius 15? With a radius 15, what means diameter 30? Okay, here is my 30 millimeter circle. I will close this sketch and I will click on a features tab and I will extrude cut through all. Now, what I need to do to replicate this pattern? I need to click under linear pattern to a circular pattern. Parameter will be my central hole that replace my axis. Items to, that's actually parameter. Features and faces. And I can choose them from a feature tree, will be a cut extrude. And there will be the secondary dowel hole. And I'm going to say that we need 6 of them over 360. Cut extrude 1 and 10 millimeters dowel hole. And look what has happened. It has automatically, with a 1 array and with only a 1, 2, 3, 4, with the 5 features in the tree, I have successfully completed this fairly complex actually geometry of the snowflake by exploiting the symmetry. And if I check the mass, mass property 132.94 grams. Okay, so now please make this coaster, and after you make the coaster, please complete the drawing of it. So already fine drawing. And that concludes this demonstration.